Hello guys, welcome back to the lecture 3 of introductory course on C++. In this lecture, we will be uh, learning about operators in C++. Okay, operators in C++. So there are different types of operators that we deal with in C++. Okay, so yeah, let's get started. So the first type of operator that we are going to deal with is unary operator. Okay, operators. Now why we call it unary? Because we we use this for using these operators we need a single variable. Let's say a is a variable. Okay, so we can implement these operators in the single variable itself. So let me give you an example. Okay, so the example is, let's say we denote an integer variable int a is equals to 5. Okay, now uh, if we want to, so I didn't give you the example of unary operator, right? So the unary operators are post increment. This is increment. Okay, simply increment. And this is decrement. Okay, now how do we use it? So let's suppose int a is equals to 5. We have declared a variable. Okay, now if we give a plus plus, if we try to execute this statement a plus plus, okay, and semicolon to end this statement. Okay, so this signifies that a is equals to a plus 1. Okay, so if a has a value 5, then a becomes 5 plus 1 is equals to 6. Okay, after this statement, uh, if we do a minus minus, then this is called as post decrement. Okay, this is called as post decrement. This is called as post increment. Okay, I forgot to tell this. This is called as post increment. Okay, so post decrement, what it does is that a is equals to a minus 1. It means, so if a is equals to 5 earlier, so 5 minus 1 it becomes, so it becomes 4. Okay, so this is how the unary operators work. Okay, so you can use these operators after the variable or before the variable, like this as well. Okay, plus plus a, this implies, okay, this is called pre-increment. Okay, pre-increment. And minus minus a called as pre-decrement. Okay, pre-decrement. Okay, okay, now what happens is, what is the what plus plus a does? It does the same thing. A becomes a plus 1, and minus minus a, what it does is a is equals to a minus 1. Now what is the difference between a plus plus and plus plus a? Okay, this I'm going to tell you within the program itself. Okay, so let's move on to the screen and let's try to write a program using unary operator. Okay, so yeah, so let's create a file. Let's say we name it operators, right? Operators dot cpp. Okay, let's write a simple body. Okay, okay, so space doesn't matter. Okay, even if you leave like 6 lines, it doesn't matter. The structure should be this way only. Okay, okay, so now let's use unary operator here. Let's say we define a variable, integer variable a, we give it a value 5. Okay, now if we try to increment it this way, this is called as post increment. Okay, post increment. Now this thing is called comment. Okay, I forgot to tell you about the comments in the previous lecture. So let's get to, let's get familiar with the comments itself. Okay, so this is called a single line comment. Like, if you use two slash, okay, and if you write anything ahead of it in that particular line only, okay, not in the second line, okay, in that particular line, so this is ignored by the compiler. Okay, this do not gets executed. Okay, so if I try to print, it will print 6. Okay, okay, sorry, it won't print anything because I haven't used cout. Okay, so let me write cout. Okay, Now if I try to print this a, the value of a becomes 6. Yeah, so 6 gets printed on the screen. Why is it so? I already told you that a plus plus signifies a, a plus plus signifies as a plus 1. So a plus 1 means a becomes the plus 1 of previous value of a. So if a was previously 5, then a plus plus is signifies a is equals to 6. Okay, plus 1 gets added into the previous value. So if I print in the third statement, if I print it, it prints 6. Okay, now what if I already incremented it. Okay, now if I do it this way, if I try to print cout a plus plus, what it prints? It prints 5 only. Okay, let's see. It prints 5. Why is it so? Because what happens is, let me take you to the screen only. So yeah, so what happens is, if I write this statement, okay, let me change the color. Okay, so if I write this statement cout a plus plus, what happens is that it it this process takes place in two steps. So in the first step it increments, okay, a equals to a plus 1, and in the next step it assigns the new value to this. Okay, okay, so when we print this, when we try to, okay, okay, so let me tell you all this thing in the next page. Okay, so what happens is that when we try to print, you know okay, I did something. So when we try to print a plus plus, what happens is, first the value of a gets printed and then it gets incremented. Okay, then it gets incremented. This happens when we use post increment. Post increment. Okay, when we use post increment. Now instead of this a plus plus, if we would have done something like this, cout plus plus a, okay, which is called pre-increment. Okay, pre-increment. So what would have happened? Firstly, the increment. Firstly, the a would be incremented. A is equals to a plus 1, and then when cout, through this statement, the incremented value of a gets printed. So if earlier a was 5, then through this statement 6 gets printed on the screen, and if the a was 5 in this case as well, so only 5 get printed on the screen, and then the value of a becomes 6. Okay, let me tell you by taking you to the Visual Studio Code. Okay, so now if I try to print this, okay, let me clear the window. So if I try to print this, it will give me 5, right? It will give me 5. But if I try to again print this a, okay, now a has become 6. Let's see. So it prints, okay, let me use endl here, endl. Okay, okay, now let's, yeah, so 6 gets printed now. Why is it so? In this statement the a only gets printed and then it gets incremented. Okay, then it gets incremented, and if we try to print it again, it gives us 6. Okay, now we got to know about about the post increment and pre increment. Let's try the pre increment also. So in this case, first the a value gets incremented by 1, so it becomes 6, and then it gets printed. Let's see. So 6 gets printed because it is first incremented and then it is printed. Okay, so similarly in the case of post decrement and pre-decrement, in pre-decrement the value of a gets decremented by 1 to the initial value. Okay, so if it was 5 earlier, so first the value gets decremented because it is pre-decrement, right? So first the value gets decremented, so value becomes 4 and then it gets printed. So 4 will be the output. Okay, let's execute. Yeah, 4 will be the output. Okay, so if we do post decrement, okay, post decrement, then in that case the value gets printed first, so 5 will be printed first, and then the value of a becomes 4. Let's see, it should print 5 on the first line and 4 on the second line. Yeah, so this is the output. Yeah, so this was all about the unary operators. Let's go, let's get back to the screen. Okay, so yeah, Now let's go to another types of operator. Okay, so the next type of operator is arithmetic operator. Okay, so these were the unary operators. Now what we are dealing with is a these are all binary operators. Okay, so unary operator requires only single variable uh, to work. Okay, these requires single variables. Okay, whereas binary operator require two variables. Okay, two variables, or yeah, two variables uh, to to be used. Now in binary operators, the first one that we are dealing with is arithmetic operators. Okay, so what are arithmetic operators? So plus, then minus, then divide, and then multiply. Okay, multiply is denoted by asterisk here. Okay, yeah, so yeah, these operators are binary operator. So if we try to write, if we declare an integer variable int a is equals to 5 and int b is equals to 10, and if we try to print a minus b, you know then it gives minus 5 as the output. Okay, let's see how these arithmetic operators work. Okay, and let's take different cases. Let's get back to the Visual Studio Code. So let's remove this. Okay, so I forgot to tell you about the comments. Okay, so this double slash, okay, acts as a single line comment. Whatever you write in front of it gets ignored by the compiler. Okay, this won't get executed when we execute the program through the code runner. Okay, nothing gets printed. Okay, and no error is given because it is a comment and it gets ignored by the compiler. Okay, now to ignore multiple lines, this was only for the single line. To ignore multiple lines like this, okay, then this, and then this, there are some statements, right? To ignore multiple lines, what we can do is enclose them within this. Okay, yeah, so this way you can enclose them, and this all three lines will be ignored. Let's see, let's execute. No errors are given and the program gets executed successfully. So yeah, this was all about, this is called multi-line comment. Okay, this that I've used. Okay, forward slash, then asterisk, and then all the statements that you want to ignore. Okay, and then again asterisk, and then backslash. Okay, yeah, so this was all about the comments. Okay, now let's get back to the arithmetic operators. So let's write the topic name. So arithmetic operators. Okay, now let's see, we declare two variables, int a is equals to 5, int b is equals to 10. Okay, now if we try to print a minus b, okay, what we get minus 5. Let's see, minus 5 we get. Okay, this is just simple, you know a into b. Okay, we get okay, so let's perform all the operations. Plus, okay, plus, and this is divide. Okay, let's see the output and let's see why we are getting these outputs. Okay, let's execute the code. So in the first case we get minus 5 as the uh, output. Okay, in the second case we get 50 because a into b, which is 5 into 10, gives 50. In the third case, a plus b, we get 15. And in the fourth case, this is very important. Okay, you need to know this thing. A divided by b, we get 0. Why we get 0? Why we do not get, why we, instead of getting 0.5, we get 0 here? So why is it so? Let me take you to the screen again. Okay, so what happens is, a was 5, right? A was 5 and b was 10. Okay, so if we divide it in C++, this division is particularly integer division. Okay, so if the division is integer division, what happens is, how many integer times it divides this value. So 5 upon 10, if we divide, okay, so it divides 0 times, right? It is obviously 0.5 when we divide it mathematically, but here the integer value is only 0, right? 0.5 is the decimal value. This complete is a decimal value, right? So by default the value gets stored in the form of an integer. So 0.5 gets ignored and only 0 is printed. Okay, this is why we get upon division 0. Okay, so if we take any of the two values as you know, as float, we'll get the answer as 0.5. Let's say I take it float. Okay, let's say I take it float, and let's say if I try to divide it now, so I get 0.5 here. Okay, so this was all. Okay, because what happens is, if we divide, you know, to convert the final division, or to convert the final value into a floating point, okay, into a floating point, what we do is either we take one variable as floating point, which I've done by taking b variable, right, which was 10. I've taken it as float. Okay, either you can take both the variables as float. Okay, float a is equals to 5 and float a b is equals to 10. Okay, this will also lend the same result, that is 5 by 10 is equals to 0.5. Okay, yeah. So yeah, this was all about the arithmetic operators. Now in the third section, we deal with the relational operators. Now what are relational operators? Okay, so relational operators are nothing but less than equals to, okay, greater than uh, greater than equals to. Okay, greater than equals to is not represented like this. Okay, rather it is represented like this somewhat. Okay, so it is represented like this. Okay, greater than equals to. Okay, uh, and then we have uh, does not equals to, and then we have comparison. Okay, so let's say, let me give you an example. Okay, where to use it. Okay, int a is equals to 5 and int b is equals to 10. I have declared two integer variables. Okay, 5 and 10, having name a and b. Okay, now if I write a is less than b, see out. Okay, a is less than b and l. Okay, so what happens is, whether a is less than b, yeah, so a is less than b, right, 5 is less than 10. So in this case, a boolean 1 gets printed on the screen. Okay, now when I write cout a is greater than b and l, okay, so it will check whether a is greater than b. No, 5 is not greater than 10, right, this is not. Okay, so in this case, a boolean 0 gets printed. Okay, now the third case, if I print cout a is less than equals to b. Okay, if I try to print this, okay, so what happens is, it will compare whether 5 is less than equals to 10. Yeah, 5 is not equal to but less than 10, so one case is fulfilled. So in this case it will print 1. Okay, if I try to print cout uh, a is greater than equals to b, none of the condition is fulfilled. Neither 5 is greater than 10 nor it is equals to 10. Okay, so in this case it will give us a boolean 0 upon printing. Okay, when we write a is equals to b, what it means, it means it asks a question. Okay, it is a question. Okay, so it asks whether a is equals to b. It asks this question. Okay, whether a, the value of a is equals to value of b. No, in this case a is 5 and b is 10, so it will give us a boolean 0 if we try to print cout a is equals to b. Okay, if we try to print this, it will give us a boolean 0 because a is not equals to b. The value of a is 5 whereas the value of b is 10, so they both are different. Okay, so the boolean value 0 gets printed on the screen. And finally, if we try to print this, okay, cout a does not equals to b. Yeah, so this condition is fulfilled, right, a is not equals to b. Okay, so in this case a boolean 1 gets printed on the screen because the condition is true. Okay, let's check. Okay, let's get back to this Visual Studio Code and let's see how is it, whether it is working or not. So let me remove this part. Okay, so int a is equals to, let's say we take it 5, int b is equals to 10. Okay, now let's try to print cout a is less than b. Okay, let's see what it gives. Okay, let's execute, but before that clear the terminal. Let's try to execute it. Okay, so it gives 1 because a is less than 10, right, 5 is less than 10. Now let's do it for every, okay, less than greater than equals to, greater than, okay, then does not equals to, and then equals to. Okay, let's remove this. Let's try to print all of this. Okay, clear, and let's try to run this. So we get 1 1 0 0 1 0. Why is it so? In the first case, a is less than b, right? 5 is less than 10, so it is true, so hence 1 is printed. In the second case, a is not equal to, but it is less than b, right? So again 1 is printed, one condition is fulfilled, right? In the third case, a is greater than equals to b, right? No, so a is not greater than equals to b, therefore 0 is printed in the third line. In the fourth line, it says a is greater than b, so 5 is not greater than 10, therefore 0 again gets printed on the screen. In the fifth case, a does not equals to b. Yeah, 5 is not equals to 10, right? So 5 is not equals to 10, the condition is true, therefore 1 gets printed. If I would have stored 10 value here, okay, the value 10 here, so in this case it would give me 0 in the fifth line, because the condition is not fulfilled. A is equals to b, right? 10 and 10 both are equal. So in the fifth case, a does not equals to b is 0. Obviously the condition is not satisfied. Let's get back to the initial, okay, values. So lastly, it asks the question a is equals to, whether a is equals to b. Let's try to execute it again. Okay, yeah, so it gives 0 because the value of a is not equals to the value of b. See, the value of a is 5, where the value of b is 10, so hence it gives 0. Okay, so this was all about the relational operators. Now third type of operators that we deal with are the logical operators. Okay, so let's get back to the screen, and let's go to the next page. Okay, so now what we deal with is logical operators. Okay, now what are logical operators? So there are three types of logical operators. First one is and, second one is or. Okay, these are the representation, how we represent them. Okay, and third one is not. Okay, so if we say we use these kind of operators when we deal with decision control statements. Decision control statements. Okay, statements. Okay, so this is used to check for the conditions. So let's postpone this for the lecture when we'll deal with the decision control statements. Okay, now will we also deal with assignment operators. So assignment operators, okay, so various types of assignment operators are equals to, plus equals to, minus equals to, divide equals to, and multiply equals to, and percentage equals to. Okay, percentage is nothing but modulo, we call it. Okay, so it gives us the reminder. Okay, now let me tell you how we use it. Okay, so this first is this is also called as the assignment operator. So we assign the value using this operator. Okay, now the second one, this one is also assignment operator. Let's say let me give you an example for this. So example would be, let's say int, I have declared an integer variable int is equals to 5. Okay, now I write a plus equals to 7. So what happens is that it also, it has the same definition as a is equals to a plus 7. Okay, so earlier the value of a was 5. Now what happens is a is equals to 5 plus 7, so 12. We get the new value of a as 12. Okay, what a minus is equals to, this second operator, for this second operator the example would be a minus equals to, let's say 5 I write. Okay, and I declare value of a as let's say 10. Okay, so a minus equals to 5 has the same definition as a is equals to a minus 5. Okay, so a becomes, initial value of a was 10, so 10 minus 5, it becomes 5. Now the new value of a will be 5. Okay, according to this. Now if we write a divide equals to, let's say I write 10, and let's say the value of a I have declared it as 20. Okay, earlier. Okay, so a divided by equals to 10 has the same definition as a is equals to a divided by 10. Okay, so the earlier value of a was 20, so a is equals to 20 by 10. Upon integer division we get 2 as the output. Okay, if the value of if the previous value of a would have been, let's say it would have been 10, let's say 9, it would have been, so the output would have been 9 divided by 10. Okay, it is obviously 0.9, but in the integer division we only take the integer part, so 0 is taken, so hence 0 gets printed. Okay, now into equals to is also the same thing. So if we denote int a is equals to, if we have declared integer variable a as having variable 10. Okay, so if we write a into is equals to 2, so it has the same definition as let me write it below. So a is equals to a into 2. Okay, so a has the value 10 previously, right? So a is equals to 10 into 2 it becomes, so a is equals to 20. Now the new value of a becomes 20. Now let me take you to the Visual Studio Code and let's see how it works. Okay, so let's erase all of this. Okay, and a is equals to 10, let's say. Okay, now this is the first operator, right? Assignment operator that we call it. Okay, now let's say I write a. We have already declared this. Now no need to write int again. Okay, so a is equals to a plus equals to 5. Okay, so what happens is initial value of a was 10, so it gets 5 gets added to it, and then it is getting, that then it is assigned to a. Okay, so it becomes 10 plus 5, that is 15. So if I try to print a now, it becomes 15. Okay, it becomes 15. Now if I try to decrement it by 5 again, it becomes 10 again, because now the value of a is 15, and now if I say a minus equals to 5, then new value of a was 15, right? So 15, so a becomes 15 minus 5, which is 10. Okay, now if I again try to print this, okay, so 10 gets printed. Okay, so for first it is incremented by 5, then I decremented it by 5, and then I again try to print it, and the value I received is 10, which was the initial value of a. Now if I similarly if I write a into is equals to 10. Okay, so it becomes, after this point the value was 10, right? The value was 10, so a becomes 10 into 10. Okay, previous value of a into 10. Okay, so it becomes 100. Let's see, in the third line we'll get 100. Yeah, oh, I forgot to print it. Okay, so okay, now let's see. Yeah, so we got 100 in the third line. Okay, yeah, so this was lastly let me tell you about the one more types of operator. Okay, so these are the bitwise operators. Okay, so yeah, so finally we are dealing with the bitwise operators. So there are various bitwise operators, okay, that we are going to deal with. Okay, so first is the bitwise OR. Okay, it is represented by a single yeah, this way it is represented this way. Okay, by single AND, this is called bitwise AND. This is called bitwise AND operator. This is called bitwise OR operator, AND operator. Okay, then the third operator is bitwise NOR. Okay, this is called as bitwise NOT operator. Then the fourth operator is called bitwise XOR. This is called XOR operator. Okay, fifth operator is right shift, and sixth operator is left shift. This is called left shift. Okay, this is called right shift operator. Okay, right shift operators. Yeah, so this was all about the types of operators. I'll tell you the use of bitwise operator in a separate lecture. Till then, goodbye.